Okay, so continuing in section 2.8, dealing with operations of functions. We just looked at in the previous video how to add, subtract, multiply, and divide functions when we put a number in. So f plus g of 2, f minus g of 3, or whatever. And so now we're going to look at, well, how do we do that with just x? And when we do this, we need to think about what is the domain? What are the possible x's that we can put in? Because there is going to be a restriction at times on what x can and cannot be. And so to find the domain of f plus g of x, f minus g of x, and f times g of x, it's going to be the intersection of the domain of f of x and the domain of g of x. Now, that seems a little wordy and complicated and maybe not be something that you understand fully. So what I'm going to suggest to you is that we wait on the domain until we have gotten to the end. When we add the functions, we multiply the functions, we subtract the functions, whatever it is. And then when we have our new function, then let's tell the domain and range. Because that's going to give us the same domain. We're actually not going to do the range, but it's going to give us the same domain. And it's going to be a lot easier because we've talked about how to find domain and range of a function. But you start thinking about, well, one function and another function, and what do they have in common, and that can kind of be sort of complicated. And so we'll do that. We'll find the domain by looking at the end function when we get finished. Now, for f divided by g of x, the domain is all x's that don't make the denominator 0. So we've talked previously in other chapters about how you can't have 0 in the denominator. And so if we end up having an x in the bottom of the fraction, which we will, then we got to figure out, okay, what makes that 0? And then x can't be that number, or numbers if it happen to be more than 1. Okay, so just kind of be aware of that. We're going to talk about that in more detail as we move through the next couple of slides. So first thing we're going to do is we're going to find f plus g of x. And so again, each of these have this alternate notation, which I find really helpful because it says that we're going to take f of x and we're going to add to it g of x. Well, can you identify f of x? Well, I sure hope so, because it says right here that f of x is x squared minus 3x. And so we're going to take that, x squared minus 3x, and we're going to add that to g of x. So can you find g of x? Well, again, I hope you're nodding your head saying yes, because g of x is in the original question. It says it's 4x plus 5. And now all of a sudden you've got two polynomials that you just simply need to add. And so how do you add polynomials? Well, you've done this before. You add polynomials by simply combining like terms. And so if you want to rewrite it without parentheses, you can, but that's not required. And so we're just going to combine like terms. The only like terms we have here are negative 3x and 4x. And so when we rewrite this, we have x squared plus x plus 5. And that's all you can do. And so that's what you get when you add these two functions together. Again, just combining like terms. Now, we want to talk about the domain. So, based on some things we've talked about previously, we should know that this is a quadratic. It's got the power of 2, and it's going to be a parabola shape. We've talked about enough graphs that are a parabola shape that you should, at this point, be able to realize, okay, this is that parabola shape. And so if you think about a parabola shape, whether it opens up or down, as it gets wider, it goes left and right both forever. And so it means here that our domain must be all real numbers because it goes forever left and right. Now, if you go back to our definition just a minute ago of how we find the domain, we said it's the intersection of functions f and functions g. Well, function f has a domain of all real numbers because, again, it's a quadratic also. So as this parabola shape opens up, it goes right and left forever. Well, the 4x plus 5 also has a domain of all real numbers because it's a line, and it's going to continue left and right forever as well. And so the intersection, what they have in common is everything. And so all real numbers there would be our domain. If you have questions about that, please let me know. Now, on the next one. Our alternate notation for subtraction says we're going to take f of x and subtract g of x from it. And so again, can you find f of x? Well, sure, it's given to us in the original problem. It's x squared minus 3x. And we're going to subtract from that g of x, which is 4x plus 5. Well, now we just need to subtract these two polynomials. Well, the one thing that's different about subtraction from the addition is that you subtract, right? But what we're going to do is we're going to take this negative because it does apply to the 4x and the 5. We're going to distribute that. I'm going to suggest you do that so you don't miss a sign anywhere. And so we're going to have x squared minus 3x minus 4x minus 5. And then we can combine our like terms there in the middle, and we have x squared minus 7x minus 5. And so that's all we can do with that. That is our new function. So this is f minus g of x. And again, our domain is going to be all real numbers because, again, it's a parabola shape. And so as it opens up or down, it's going to continue to get wider. And so it's going to go forever in both directions. So it's, again, negative infinity to positive infinity. And again, we said it's the intersection of the two functions. And so those two functions do give us that domain because they have everything in common. So look at the next one. We're using the same two functions here, but this time we're going to multiply. And so remember our f times g of x, that alternate notation is to take f of x and multiply it by g of x. And again, f of x is x squared minus 3x. And we're going to multiply that by g of x, which is 4x plus 5. And so then we can simply multiply those. Well, how do you multiply binomials? Hopefully you know that you can FOIL, distribute, box method, however you want to think about that. But hopefully that's something that you can do without a whole lot of issues. And so if you do the FOIL method, first outer inner last, x squared times 4x is going to be 4x cubed. X squared times 5 is 5x squared. So just distributing this. And then we also distribute the negative 3x. So negative 3x times 4x is going to be negative 12x squared. And negative 3x times 5 is negative 15x. And again, we have like terms in the middle that we need to combine. And so we'll have 4x cubed minus 7x squared, because 5 minus 12, minus 15x. So that is our new function again when we multiply those together. Now, again for the domain, this one is a cubic equation because the power of 3. And we haven't talked much about this type of equation, what the graph looks like. But you can again think about, well, what x's can I put in? And so what do I do to a number if I were to put it into this function? Well, I'm going to cube it. I can cube positive numbers, or I can cube negative numbers, or I can cube 0. I can cube anything, right? And then I can take any number and multiply it by 4. And then I need to square that same number. Well, I can square any number. I can square 0, I can square positives, square negatives, and I can multiply that by -7. And then I can also multiply that number by -15, and then I can add or subtract any of those. And so because x can be any number, we can put any number in. Again, our domain here is all real numbers. And again, if you think about the intersection, all the x's in the domain of function f is all real numbers, and all of them in function g are all real numbers, and so what they have in common is obviously all real numbers. Now, look at the last one. So this one, again, we have an alternate notation that says that we're going to find f of x divided by g of x. And so again, we know f of x, it is x squared minus 3x. And g of x is 4x plus 5. Now, we're not going to try to divide that. We're going to leave that just like it is. If it were something very simple to divide, we would try to do that. But this one is not all that simple. Later, we'll talk about how to do some division that is pretty easy. But for this, we're just going to leave it. So that's going to be our new function. And we, again, want to think about the domain. So the domain is going to be any number that doesn't make this denominator be 0. And so the question is, well, how do I know what makes that be 0? Well, we can write an equation that says that 4x plus 5 can't be equal to 0. If we solve, we'll figure out what x can't be. And so you subtract 5, and we get 4x is equal to -5, and we'll divide by 4. And you find out that x can't be -5/4. And so what that tells us then is that our domain can be anything but -5/4. And so in our interval notation, we say it's everything from -infinity up to -5/4. We're not using that number, so we put in parentheses. And then it's in union with everything from -5/4 to positive infinity. And so that is our domain. If you have any questions about adding, subtracting, multiplying,